What's up? I'm Vin, and today I want to go through the New York State Grade 7 math test from 2023. And these are the release questions. I'll leave a link to these questions in the description below. So let's get started. So first up here, we want to divide these two fractions, and we're going to use keep, change, flip. So to use keep, change, flip, you just have to keep the first fraction the same. So we have -1/3. Then you change the operation to multiplication, and then you flip or find the reciprocal of the second fraction. So we're going to flip 2/5 to 5/2. And now we're just multiplying fractions here. We have -1 times 5 is -5 over 3 times 2 is 6. Just remember, when you multiply fractions, you just multiply the tops and the bottoms. So we have -5/6, and this is going to match choice B. Question 2, Maria and two friends are at the movie theater, and they have $52 to spend, and so far they spent $34.50 on movie tickets, and they bought 3 drinks that each cost the same amount. And after buying the movie tickets and drinks, they have $4 remaining. So we want to know how much did each drink cost. Okay, so that's the actual question. So for this one here, we could start by subtracting the total amount of money they have by the amount they spent on movie tickets. So they spent $34.50. And for this, we could use a calculator, but I'll just go ahead and do the long subtraction. We have 0 minus 0. We borrow from here, make that a 1. 10 minus 5 is 5. And then borrow to make this a 4. And 11 minus 4 is 7. 4 minus 3 is 1. So there is $17.50 left after the movie tickets. So now let's think about this. They also bought 3 drinks that cost the same, but after they bought the drinks, they had $4 left. So what we could do is we could subtract the $4, and this will tell us how much they spent on drinks. So if we subtract this, we're going to be left with $13.50. Because be mindful, if you think about it, they spent $13.50 on drinks, and they spent $34.50 on the movie tickets. And if we add those two values together here, this is going to work out to $48, which definitely tells us they have $4 remaining, because that would bring us back to the total 52. So this is the amount for drinks. Okay, drinks cost $13.50. So if we want to know how much each drink costs, they all cost the same. We're just going to divide this by 3. So once again, I could use a calculator, or I could say 3 goes into 13 4 times with a remainder of 1. I'm going to put the decimal up. And then 3 goes into 15 5 times. 3 goes into 0 0 times. So $4.50 is the price of each drink. So question 4, Megan reads the same number of pages in a book each day. Okay, so this is really big here. Same number of pages each day. And the table below represents the total number of pages read at the end of a given number of days. How many pages does Megan read in one day? So for this one here, once again, Megan is reading the same number of pages each day. So that means that this table here is going to be linear, is a constant rate of change. So we could think proportionally here. You could think about, let's say I take 32 pages in 2 days. If I want to find out how much Megan reads in one day, I could divide the top and bottom by 2. And this will tell us that Megan reads 16 pages in one day like this. Okay, so 16 pages in one day. Choice A is our answer. Now, look, if you wanted to be really sure here, you could take 64 pages. Like, let's say I take this row, 64 pages in 4 days. And for this one, if you were to divide the top and bottom by 4, you would still get 16 pages for every one day like this. Still getting choice A. Question 5, we want to know which expression is equivalent to the one shown below here. So we could simplify this and simplify all the answer choices, but that might take a while. I'm looking at this and seeing there are 4 terms in this expression, and all the answer choices only have 3 terms. So it looks like they added a pair of terms here. And just scanning the answer choices, it's looking like they're adding these 2 terms. So if I want to add those 2, what I'm going to do is I'm just going to switch these 2 using commutativity of addition. So I have -1.5 plus I have -7 plus 2/5 plus 2.6. And you could see here, if I add these 2 terms, I have -1.5 plus -7. That's going to give me, we're going to have -8.5. Okay, in my head, what I'm essentially doing here when I add those is, notice how they both have a negative. It's kind of like using the distributive property. I have negative, and then I just add 1.5 plus 7, and that's going to give me -8.5. That's where this is coming from. And then I have plus, and when I scan the answer choices, it looks like they did one more commutativity of addition here. They switched these 2. So I have -8.5 when I combine those 2 terms, and then I'm going to have 2.6 plus 2/5. And then I could just choose to throw parentheses over this sum here like this. That's not going to matter. And now when I scan the answer choices, this is going to match up with choice B. Question 8, Joel has 3 buckets which contain different amounts of liquid, and the amount of liquid in each bucket is listed below. And what we have is Joel mixes all the liquid together, and then he pours all the liquid equally into 5 containers. How many liters of liquid does Joel pour into each container? So for this one, the fact that Joel is mixing all the liquid together, that means we're going to add these 3 values up here. So I'm going to convert these into improper fractions. I'm going to multiply. I'm going to have 7 times 2, and then I'm going to add the numerator. So I have plus 1 over the old denominator. So this one would work out to 15 over 2. And if I do that for the others, so this is 15 over 2 liters. If I do that to the others, I do 4 times 5 is 20, plus 3 is 23, and we're dividing by 4. And then for the last one here, we have 4 times 6 is 24, plus 3 is equal to 27, and we're over 4 like this, liters. So now I'm going to add these 3 together because Joel is mixing all the liquids together. So we're going to do, and I'll write the units at the end, and we're going to have 15 over 2 plus 23 over 4 plus 27 over 4 like this. And we're talking about liters here. So now this one I would convert. I'm going to multiply this fraction by 2 over 2 so that it has a matching denominator to the others. So this sum here is going to be equal to, we're going to have 30 over 4 plus we have 23 over 4 plus 27 over 4. And I could use a calculator here to add these numbers, but I could just do this in our, we'll just do this in our head here. So you have 23 plus 27 is going to give us 50, and then 50 plus 30 is going to give us 80. So we have 80 over 4 liters like this, and this is equal to 20 liters. But we have to be careful here. Remember, the question is asking us how much liquid is in each container. This total amount of liquid is being poured equally into 5 containers. So this language here is telling us to divide by 5. Okay, so we just need to divide that total amount by 5. So we're going to take 20 liters and we're going to divide it by 5. And that's going to be equal to 4 liters, which is going to match up with choice B. So question 9, we have a student's science scores are shown below. We want to know what is the mode and how does it compare to the median. Well, to find the median, we need to make sure that this data is in order from least to greatest. So let's go ahead and organize it. So the smallest value in the list is 45. So I'm going to write we have 45 here, and I like to underline it so that I could keep track of what I already wrote. So then after 45, 63 looks like the next smallest number. So we have 63, and then after that would be 65. And scanning this looks like 74 is going to be the next smallest value, and then 76. And then after 76, it looks like 82 is the next smallest. And 82 shows up 3 times. So I am going to write it 3 times like this. So that's telling me right away our mode is going to be 82. Remember, the mode is the one that shows up the most frequently. So 82 in this case is going to be our mode. But we still have 2 values left. We have 90 and we have 93. Okay, so now that everything's accounted for, to find the median, what I like to do is I like to cross off the first number and the last number, and I like to repeat this until I get to the middle. So I just keep going like this, and then we do this, and you're like, oh no, I have 2 values, so which one's going to be my median value? Well, to find the median when you have 2 values left in the middle, you're going to take the average of these 2 numbers. So you're going to take 82 plus 76, and you're going to divide it by 2. Now, a little mental shortcut that you could use, although you do get a calculator, so you could just type this in, is I think 76 and 82, those are 6 away from each other. So if I think of the number line, 76 and 82, those are 6 away from each other. So the median is going to be in the middle of those 2. So I could just think, oh, well, half of that distance would be to go forward 3. And if I did 76 plus 3, that would give me 79. I could also do 82 minus 3, and that would also give me 79. So I could just cut the distance between them in half and either add it to the smaller number or subtract it from the bigger number. So you could go ahead and work this out, but I promise it's going to work out. Let's just make that neater. This is going to work out to 79. So that's our median. So now we just have to go through the answer choices and match it up. So we have the mode is 79. That's not true. That's the median. So I could eliminate these 2 choices. So these 2 are in the running. But if we think about this, the mode is greater than the median. Okay, so the mode is 82 and it is lower than the median is not true. It's going to be greater than the median or higher than the median. So choice D is definitely our solution. Question 13, we have a table showing how much money Kathy earns babysitting for a certain amount of hours. And this column is H, the number of hours she works, and this column is D, the amount of dollars that she earns. And based on this table, which statement is true about the relationship between the number of hours that she works and the amount of money that she earns? So for this one, the answer choices are saying not proportional, proportional. So these phrases are showing up everywhere. So the first thing that comes to mind when I hear those, well, I think if these points are in proportion, so we have a graph here of H hours versus D dollars. If these points are in proportion, that means when we plot these points, they're going to form a straight line. So that's what I'm looking for when I approach this question. And if we look at the answer choices, I'm doing some mental math and I'm saying that this is proportional, which is going to lead me towards choices B and D. But now we look at the reasoning. And choice D is a very dangerous bear trap. Now, the reason why choice D is no good is because if we look here, the values of H increase by the same amount from one pair of values to the next. Well, for one, the values of H are not increasing by the same amount. Notice from 6 to 9 here, it's increasing by 3. But that wouldn't be a valid reason for these points to be in proportion anyway. What we would need to happen is that the value of D increases by the same amount as the values of H increase by the same amount. So that would need to be mentioned in this choice for this to be a valid reason. So that's why this one is out. But if we want to be 100% certain that choice B is correct, let's check that the ratios between D and H are the same all throughout. So if we do 50 divided by 4, so we're going to divide the first two values here, that's going to give us 12.5, which models that Kathy is earning $12.50 per hour that she works babysitting. And now if we do the next entry here, we have 62.50 divided by, and that would be earned from working 5 hours. So we're going to divide this one by 5, and notice it gives us the same exact amount. But we can't get lazy here. We're going to have to check all throughout because maybe the last value is sneaky. But if we do 75 over 6, we're still getting 12.5. And now for the last value, we have 112.50. So for that, we're going to just type that in, and we're going to divide it by 9 for the 9 hours worked. And we also get 12.5. So question 16, we have math test scores for Class A and Class B, and they're represented by these box plots, commonly known as box and whisker plots. Okay, let's get back to the question now. So we have which statement about the relationship between the scores of the two classes is true? Well, one thing you want to know is what does each piece of the box and whisker plot look like? So you look at the whiskers here. The whiskers represent the minimum value and the maximum value. So this I'll just abbreviate. So we have the minimum and the maximum. Now, this first part here, the beginning of the box, represents the first quartile. Okay, so this is the first quartile. And then inside the box here, that second line represents the median. So this is the median. And then this last part here of the box represents the third quartile, which I'll just abbreviate here with QU like this. So now we're ready to go through the answer choices. So for choice A, we have the median score of Class A is greater than the median score for Class B. So what we should identify is what is the median for Class B? And you can see here that the median for B is definitely greater than the median for A because it's more to the right. It's at about almost 94, and this one is at about 83 in that neighborhood there. So Class B has a greater median, which means choice A is out. So now we're talking about the range, and this is going to be the maximum minus the minimum. So we're talking about the max minus the minimum for Class A, and we're comparing that to Class B. So here, I'm just going to talk about what is the range. So the range for A. And if we look at this, well, the range is going from at about 66 to almost 96. So I would say here, it's like almost 30, but a little bit less. Okay, so it's very close to 30. But if we look at B, for Class B, we're going from 75 to 100. So this one is exactly 25. So this one, we're a little bit less than 30, but that's definitely more than 25. So A would have a greater range, not a lesser range. So B is also out. So now we're looking at the interquartile range. So this is really just a lot of vocabulary. The interquartile range is going to be Q3 minus Q1. So it's kind of like the length of this box here. So if we look at Class A, and I'm going to abbreviate, we have interquartile range like this. And I'll do it for A and I'll do it for B. So for A, the interquartile range, we're at about 77 in that neighborhood. And here we're almost at 77, so I would say almost 10. And then if we look at B, the box goes from 85 to more than 95. So this one, almost 10, this is clearly greater than 10. So B would have a greater interquartile range. So the interquartile range for B is greater than the interquartile range for A. This one is definitely sounding good, but now just to be 100% safe, I'm going to rule out choice D. So we have the second quartile value. Well, the second quartile value is the same thing as the median. So the second quartile value for B is less than the second quartile value for A. And if we look here, for B, this one is greater. You see how this one here, once again, is almost at 94, whereas this median, the second quartile, at about 83. So the second quartile for B should be more than, not less than. So that's why this is out, and choice C is our solution. Question 17, we have the design of an office parking lot shown below, and we're told the distance between each parking space is X feet. And we want to know, what is the distance X between each parking space in the parking lot? So one thing to be mindful of here is that the total distance across is 50 feet. So that's from one end here all the way to the other. But then we have this distance here is 8.5. And notice that we have 5 cars here. So each of these distances are going to be 8.5. So if I want to find the total distance of the parking lot, I'm going to have to take into account that we're talking about 5 cars here, and they're all equally spaced. So what we're going to use here, we're going to have 8.5 times 5, since there's 5 cars going across like this. But then we're going to add here, we're going to have 1, 2, 3, 4 x's. So we have plus 4x, and that's going to be equal to 50. Because once again, notice we go 8.5x, 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 and then 8.5 once more like this. So we're going 8.5 5 times, and we're going x 4 times, and that's going to cover 50 feet. So now we just have to do the arithmetic. We're going to have 2 times 8 is 16, plus 1 is 17. So that's 17 over 2 times 5, and 5 I'm going to call 5 over 1. And then we have plus 4x is equal to 50. So now we just have to simplify. 17 times 5 is going to give us 85, and we're dividing by 2, and we have plus 4x is equal to 50. And this I could just go ahead and call 100 divided by 2. And the reason I'm doing this is so that when we subtract 85 over 2 on both sides, notice now that we have common denominators, so we could simplify things nicely. So this is going to cancel out here, and I'll write the result over here. We have 4x equals, and when we do 100 minus 85, that's 15, and we're over 2 like this. So now we want to solve for x. We're going to divide both sides by 4. But just know, dividing both sides by 4 is the same thing as multiplying both sides by 1 over 4. Because when I do 1 over 4 times 4, that's equal to 1. So those are just going to cancel out, and we'll have x equals, and we're going to have 15 times 1 is 15, over 2 times 4 is 8. Now notice that answer doesn't show up, so we have to turn this into a mixed number. So 8 goes into 15 once with the remainder of 7, and we're dividing by 8. So this would be 1 and 7/8, which is going to match choice C. So question 18, we have a student with a bus pass, and they have a balance of $30 on their bus pass. And each time the student rides the bus, the balance on the bus pass decreases by $225. What is the greatest number of bus rides the student can take using the bus pass? So for this one here, their balance is $30, and we're going to be dividing by $2.25. So this is what we're dividing by like this. Now, we could do long division, but we do have a calculator, so we could just do 30 divided by 225 like this, so $2.25, and this is going to work out to 13-point repeating 3. So we have 13-point repeating 3 like this, but we need to interpret this answer in the context of the question. The greatest number of bus rides needs to be a whole number, because you can't start the bus ride and then they just throw you off the bus 1/3 of the way there, okay? Once you get on the bus, that counts as a bus ride. So here, if they could afford 13-point repeating 3, they're not going to let them on for that 1/3 of a bus ride. So they could only afford 13 full bus rides. So choice B would be our answer. Question 21, we have a store selling blue hats and green hats, and each hat is priced at $8, and the expression 8B plus HE can be used to determine the total price when a customer buys any number of blue hats B and green hats G. Which equivalent expression could also be used to determine the total price in dollars of the hats? So for this one, this is very wordy, but it's kind of like unnecessary, all those extra words, because we're just looking for an expression equivalent to this. So this, if you factor out the 8 here, you're left with B plus G, and this would match up with choice C. Just know this is called factoring, but you could also think of this as the backwards distributive property. Because if we took our answer here and we distributed, notice we would get 8 times b plus 8 times g, and this would match the initial expression here. So choice C is definitely our answer. Question 23, we have a store manager collecting information about the number of people that visit the store each week. And this information is collected over a 3-week period. And the information is listed here. The number of people that visit the store in week 1 was 3,200. So we'll say over here, week 1 is 3,200. So now for week 2, there is a 10% increase compared to week 1. So now just know, if you want to increase something by 10%, one thing you could do is we could take 3,200 and we can multiply it by, just know 10% is the same thing as 10 out of 100. And as a decimal, that is 0.10 like this. So we could multiply 3,200 by 0.10 and then add that back on to the original 3,200 because we want to increase 3,200 by 10%. So we take 10% of 3,200 and add it on. But there's a faster way to do this. What you could also do is just take 3,200 and you could multiply it by 1.10, which would be the result of what I'm thinking of here. That's the result of adding 100% plus 10%. Because anytime you have a 10% increase, you're increasing the original 100% by 10%. And this would just be 1 plus 0.10 because 100 is 100 out of 100, which is 1. And if we add these two, that's where we're getting the 1.10 from. So this is just a nice little shortcut to increase something by 10%. So now we can just type this in. We have 3,200 and we're multiplying by 1.10. So we have times 1.10 like this. And notice here that we have our 10% increase, 3,520. So for week 2, we have 3,520 people visiting the store. But now we're looking for week 3. So we have to be careful here. Don't fall in the trap of choosing choice A. So what we need is for week 3, we have the number of people that visited the store in week 3 was 15% more than week 2. So what I'm thinking of right away here is if I want to go 15% more, that's 100% plus 15%. And that would give me, we would have 1 plus 0.15 like this, which is giving me 1.15 like this. So I would multiply week 2, the 3,520 times 1.15, and this would increase this amount by 15%. So we're just taking this answer and multiplying it by 1.15 like this. And then our final answer is going to be 4,048. So for week 3, we have 4,048 people visiting the store. Choice D is our answer. Question 25, we have Joseph has a part-time job and the graph below shows the amount he earns in dollars for the number of hours that he works. Based on the graph, which equation can be used to determine the earnings in dollars for every hour he works? So what I noticed right away is that this is a linear graph. These points form a straight line and we're starting at the origin here. So this would be a direct proportion. We could say that X and Y are directly proportional, which means they satisfy this equation here. Y equals K times X, where K is a constant. Okay, and K represents our rate of change, which tells us just how steep this line is. So what we could do to solve for K here is we could pick a random point on this graph. Other than 0, 0, we're going to pick this point here at, it looks like 2, 30. And I know this is 30 because the y-axis is counting by tens. So this would go up to a height of 30 here. And 2 is my x, 30 is my y. And I would just plug into this equation here to solve for k. So I have 30 equals, because y is equal to 30, and we have k times x is equal to 2. So then to solve for k, just divide both sides by 2. And now 2 divided by 2 cancels. And I'm going to have k left, and that's equal to 30 divided by 2, which is 15. So now I plug it back into this equation here, and I'll have y equals 15 times x. And that is going to be the equation of this line. Now, if I wanted to be 100% certain here, I could just pick out another point here, like let's say this point here at 6, 90 like this. And notice my x is 6 and my y value is 90. And if I plugged in, let's say x equals 6, notice I would get y equals 15 times 6. And 15 times 6 is equal to 90, which matches the y value of this point here. So choice B is looking good. Question 31, the line plot shown below represents the number of hits by some players at a baseball tournament. So how many players are represented by the data on the line plot? So for this one here, we have to be very careful. Notice that the line plot is modeling the number of hits at a baseball tournament. So each of these X's actually represents the players. So if we want to know how many players are at this tournament, we just have to count here. So we're going to count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Choice C would be our answer. Please do not fall in this dangerous bear trap. Okay, a lot of students are going to read this way too quickly, and they're going to calculate how many hits are represented by the data. And they're going to go, okay, well, 3 people got 0 hits, plus there's 1, 2, 3, 4, 5, 6, 7. 7 people got 1 hit, plus we have 1, 2, 3, 4, 5. 5 people got 3 hits, 4 people got 4 hits, 2 people got 5 hits, and then we have 1, 2, 3, 4, 5 people got 6 hits, and only 1 person got 7 hits. And then if you simplify, that's 0 plus 7 plus 15 plus 16 plus 10 plus 30 plus 7. And if we start to work this out, this is going to make 40. If we work this one out here, that's 22. So we have plus 16 plus 40 plus 7 like this. And if we keep adding here, let's just close this out here. This is going to give us, we're going to have 38 plus 40 plus 7, which works out to 85. And there's actually an answer choice waiting for us here. So all of this work when all we had to do is just count the number of X's. So remember, make sure you are reading very, very, very carefully. Okay, this is the $1 million phrase right here. Make sure you're counting the number of players. Question 32, we have the bill for a dinner at a restaurant is $58.20, and this is before sales tax and tip. So sales tax is 5% of the dinner bill, and tip is 20% of the dinner bill. How much is the total bill, including tax and tip? So for this one here, what we want to be able to do is we need to be able to say here 5% is 5 out of 100, and this is equal to 0.05. Now, if you're not sure, you could just type that in a calculator and it'll write this decimal here, but be careful not to fall into this dangerous bear trap. Some people would confuse this with 50%, which 50% is 50 out of 100, which would be 0.50. So just make sure you include that extra 0 after the decimal. And now we've got 20%. 20% is 20 out of 100. And this we could just say is 0.20. So then what we have here is the total bill is going to be the bill before sales tax and tip, which is $58.20, plus this represents here the tax. So we have to include the tax here. So we're going to take the total bill and we're going to multiply it by 0.05. So we have to add that to the bill. And now what we also have to include here is tip. So we're going to be tipping 20% of the pre-tax amount. So we're going to be doing $58.20 times 0.20. And the rest is calculator work. So we just have to type this in. We've got $58.20 like this. And we're going to be adding here. We have $58.20 times the 5%. So we're multiplying by 0.05. And then we have one more thing to work out here. We have $58.20 one more time. And we're multiplying this by 0.20. That's the 20% tip that we're including here. And this works out to $72.75 choice B. Now, just know what you could also do, this is a little bit more advanced, is you could take the $58.20 and say they have to pay 100% of the bill. So that's the 1, plus they have to pay 5%. So I'm going to add 5% as a decimal. And then they also have to pay 20%, which is 0.20 like this. So if we were to write it out like this in the calculator, notice that we get the same exact answer just like this. So either way, choice B is our answer. So once again, our total was $72.75 and we're going with choice B. A bicyclist travels 6.5 miles in 2/3 hours. What is the average speed in miles per hour of the bicyclist? So for this one here, the bicyclist is doing 6.5 miles in 2/3 hours, but we want to know how much they're doing in 1 hour. What's their mile per hour rate here? So we're finding the unit rate, which means we're going to divide these two numbers. So I'm going to convert the top here to an improper fraction. 2 times 6 is 12, plus 1 is 13. So the top number is really 13 over 2. So we have 13 over 2 miles over 2/3 hours like this. So now we just need to divide these two fractions. And the technique we're going to use is keep, change, flip. So we're going to keep the top here as 13 over 2. We're going to change this to multiplication because fraction means divide. And we're going to flip the bottom to 3 over 2. And the units now are miles per hour because we have miles over hours. So this I'm just going to abbreviate as MPH for miles per hour. And now just do the multiplication. 13 times 3 is 39 over 2 times 2 is 4. And this is miles per hour. And now I'll just go on a little side quest here and do 39 divided by 4. 4 goes into 39 9 times, and that would get us as close as 36. We would have a remainder of 3. So we'd have 3/4 like this. So the bicyclist is going 9 3/4 miles per hour. I wonder if this bicyclist is Harry Potter. If you get the reference, then awesome here. But our solution is 9 3/4. So question 34, we're at a deli and customers are buying sandwiches and they can choose one type of bread, one type of meat, and one type of cheese. And the options are listed here. Assuming each choice is equally likely, what is the probability that a customer will choose a sandwich with white bread, turkey, and Swiss cheese? So for this one here, what we could do is we could find the total number of sandwich possibilities using the multiplication principle. So there are two types of bread. There's white or wheat. And we're using the multiplication principle. We're going to multiply by the number of meats. There's two types of meats. There's turkey or beef. So we're doing 2 times 2 so far. And then we have to multiply by the number of cheeses. There's 3 cheeses. There's American Swiss cheddar. So that's 3 cheeses. And now we do 2 times 2 is 4 times 3 is 12. So there's 12 types of sandwiches in total. Okay, that's how many possibilities there are. And this is just one possibility. This sandwich is one possibility out of the total 12, which would give us choice A. Now, if that doesn't make a whole lot of sense, we could do this the long way and make a tree diagram. And we could start with the bread. There's white or there's wheat. And now we'll go ahead and make our tree here. Off this first part of the tree, we're going to talk about the meats. There's turkey or beef. And now we could finally abbreviate because the letters are different. So we have turkey and beef going this way. And then now that we've talked about the meat, we could talk about the cheeses. There's American, Swiss, cheddar. So that's American, Swiss, cheddar. And we're going to do this for the other ones. We have American, Swiss, cheddar going all the way like this. Now, this works because 12 is not a giant number. But let's say there was like 10 types of cheeses and like 8 types of meats. I'm not making a tree diagram because that's going to take up my entire test paper. Okay, so this is all the possibilities. Now, if you think about it, our sandwich was white bread and then it was turkey. So it's like we're starting at white bread, we're going to turkey, and then we're going to Swiss cheese, which is right in the middle here. So notice this is one option out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total options. At the end of your tree diagram, that tells you how many total possibilities you have. But either way, choice A is our solution. Question 35, we have Frank is riding a taxi to get to work. And the cost of riding the taxi includes a one-time fee of $275. And they also charge $260 per mile. If Frank rides for 4 miles and pays a $2 tip, how much money will he have left over if he pays with a $20 bill? So for this one here, there's a lot going on, but ultimately what we're doing is we're going to find what is the cost first of riding in this taxi for 4 miles. So there's a flat rate of just $275 just to get into the taxi. And then they're charging you $260 per mile. So if we do $260 times 4, that's going to tell us how much money Frank is paying to go 4 miles. And he also gives a $2 tip. So we would just have to work all of this out. Now, this we could just do in a calculator, but why not practice some of our arithmetic on the side here? So 260 times 4, 4 times 0 is 0, 4 times 6 is 24, we carry the 2, and we have 4 times 2 is 8, plus 2 is 10. So this will work out to 1040. So we have 1040, and then we're going to be adding 2, and we're going to be adding 275. So this is something I could just do on the side here. I'm going to add, we're going to have $2 being added and 275 like this. So if we work this out, that's 5, 11, carry the 1, gives us a 5, and then we bring another 1 down like this. So that's 15, 15. So now how much change will he have if he pays with a $20 bill? Well, the total amount of the taxi ride is 15, 15. So we subtract that from the amount of money he's paying with. And now we just have to borrow here. This is going to become a 1, making this a 10. And then we borrow from this to make this a 9, to make this a 10. And we borrow again to make this a 9. And this is a 10. Now, that's a little bit of extra work to do here, but whatever. We'll just work this out. 10 minus 5 is 5. 9 minus 1 is 8. We bring down the decimal. 9 minus 5 is going to give us 4. And then we have 1 minus 1 is 0. So we're not going to write a 0 here. We have $4.85 is Frank's change. Choice A is our solution. So question 36, we have the sum of 2 numbers is 0. If one number is 5, what is the other number? So for this one, we want to know what is the additive inverse, okay? And the idea behind the additive inverse is that when I have something like, let's say A plus negative A is equal to 0. So you just take the opposite of that number, and when you add the opposite of a number, it's going to give you 0. So here, if I'm starting with 5, 5 plus blank is equal to 0. I know that mystery number has to be negative 5 because of the additive inverse here. So 5 plus -5 would be equal to 0, and choice B is our answer. So question 37, Miss Jacobs has $15 to spend on coffee and donuts. She buys one coffee for $2.59, and the cost of each donut is $1.09. Which inequality could be used to determine the greatest number of donuts, D, that Miss Jacobs can buy? So for this one here, we have to be mindful that Miss Jacobs only bought one coffee. So this is a fixed amount, okay? So we're not going to attach this to a variable. We're just starting with a fixed amount here of $2.59. So just think of this side of the inequality as the total bill, okay? So this represents our total bill. So what we're looking at here is that the total bill, and I'll label it as such over here too. So we have the total bill is going to be $2.59 plus each donut is $1.09. And if D represents the number of donuts that Miss Jacobs is going to buy, we're just going to attach that variable at the end of the $1.09 like this. So this would tell us the total bill that Miss Jacobs has when she goes to the register. But remember, Miss Jacobs has $15 to spend. So the total bill cannot be more than $15. The total bill has to be less than or equal to 15, because if the total bill were more than 15, then Miss Jacobs would not have enough money. So that's why we're going with less than or equal to, which right away is going to eliminate choice B and choice D. And now we just look at the answer choices here and see the difference is that the $1.09 represented the cost of each donut, and the variable for donut was D. So that's why the $1.09 needs to have the variable next to it. And remember, $2.59 was the fixed amount. So that's why this is going to be choice A, and we could eliminate choice C. Question 38, Maggie owns a dog grooming business, and the price for 2 services are listed below. And we have a customer receives an 18% discount when paying for both a dog wash and a nail trim. What is the total price the customer will pay for a dog wash and nail trim with the discount? So for this one here, what I'm thinking about is that if the customer is getting an 18% discount, that means they're getting 18% off. So this is a nice little trick that I like to use. If they're getting 18% off, what I like to think about is what percent is staying on. So 82% of the original price is staying on. And where am I getting that from? Well, if we start with 100% of the price, they're getting 18% off. So that's being subtracted from 100. And that tells us what percent they're going to still have on. And 100 minus 18 is 82. So they still have 82% on. And the reason why I like to do this is because it's much easier to just multiply by 82% than it is to take 18% of the bill and then subtract it. So it's just less work to do if we do it this way. So now let's think about what is the total cost before the discount. Well, if we add $31.50 plus 17 like this is going to work out. We're going to have $48.50 like this is the total bill before the discount. But now all we have to do is take $48.50 and we're going to multiply it by 82%. But remember, turning a percent to a decimal, this is going to be 82 out of 100, which would be 0.82 like this. So I'm just going to multiply this by 0.82. So we have $48.50 and we're multiplying this by 0.82. So we have times 0.82, and this is going to tell us that our final answer is $39.77. So this works out to $39.77, and this is going to match up with choice B. So question 39, we have the table below shows a proportional relationship between the cups of flour X and the number of cookies Y for a given recipe. Based on this relationship, how many cookies can be made per cup of flour? So since we have a proportional relationship here, we could take any row from this table. And let's say I go with this row because I'd rather work with whole numbers. And what this tells us is that we could make 48 cookies when we use 3 cups of flour. Okay, so for every 3 cups, we get 48 cookies. But the question here is how much could we make per 1 cup of flour? So for this, if we want to get 1 cup of flour, what you could think of here is how do you get from 3 cups to 1 cup? And we would have to divide by 3. And if I divide the bottom by 3, I would have to divide the top by 3 as well. And 48 divided by 3 is 16. So we're going to get 16 cookies for every 1 cup of flour. So we could just record our answer. We're going to get 16 cookies. So question 40, we have Casey and Andrew each went for a walk once a day for 4 days. And we have Casey walked 3/4 of a mile each day. Andrew walked 3/5 of a mile each day. And at the end of 4 days, how much farther in miles has Casey walked than Andrew? So for this, I would just calculate how far do each of them walk. So Casey walked 3/4 of a mile each day, but for 4 days. So if we do 3/4 times 4, this tells us how many miles that Casey walked in total. And if I do 3/4 times 4, just know that 4/4 cancels, and that's going to give us 3 miles. So that's how far Casey walked. Now for Andrew, we're going to take Andrew's rate, and Andrew is walking 3/5 of a mile each day. So we're going to do 3/5 times 4 because, once again, Andrew and Casey are both walking for 4 days. So not 4 days straight, but 3/5 of a mile each day for 4 days in a row. So if we look at this, this is going to tell us how many miles that Andrew walked. And we're going to multiply it by 4. And we could just call this 4/1. And now I'm doing 3 times 4 is 12. Over 5 times 1 is 5. And this is in miles. So now we want to know how much farther in miles has Casey walked than Andrew. So now we're just going to subtract here. We're going to do 3 minus 12/5. And to work this out, I'm going to call this 3/1. And I'm going to multiply this fraction by 5/5. That way we get a common denominator. So we're going to get 5 times 3 is 15 over 5 minus, we're going to have 12/5. The second fraction we leave alone because now we have matching denominators. And 15 minus 12 is 3. So we get 3/5. So we can record our answer here. Casey walked 3/5 miles more than Andrew. So question 41, we want to write this expression as the sum of two unlike terms. So what we could do here is we're going to take this expression and we're going to combine like terms on the inside because that's inside the parentheses. And when we look at order of operations, this tells us that we can look at parentheses exponents first. So we're going to look inside the parentheses and combine these like terms. So we're going to have 18y minus 2y is going to give us 16y, since we're just going to be subtracting the coefficients, the numbers in front. We're doing 18 minus 2 is 16, and we just tack on the y, and the plus 10 just follows along. And now the next thing we could do here is use the distributive property. So we're going to multiply here. We have 1/2 times 16y. So we're going to get 1/2 times 16y plus we have 1/2 times 10. And for this one here, we could just think, what's half of 16? That's 8. So we have 8 times y. Plus, we're doing half of 10, and that's going to be 5. So here's our expression. Now, just know another option here is we could start off with the original expression, and we could distribute the 1/2 to all 3 terms like this, and then combine like terms after we distribute. And if we do it this way, we have 1/2 times 18y is going to give us 9y. We have 1/2 times minus 2y is going to give us minus 1y, since we're doing a positive times a negative, which would be a negative. And then we have plus 1/2 times 10 is 5. And if we combine like terms here, if I have 9y minus, there's an invisible 1 in front, minus 1y, that's going to give us 8y plus 5. So either way, we get 8y plus 5. So question 42, we have a student programming a robot, and it's traveling at constant speed across the classroom floor. And the table below shows the relationship between the distance in feet the robot travels across the floor over a period of time in seconds. So first we want to write an equation to represent the distance d in feet that the robot travels in t seconds. And then we're going to use this equation to see how many seconds will it take for the robot to travel 11 feet. So for this one, what we're told here is that the robot is traveling at constant speed. So just know that this is going to be a situation where we're thinking of that formula y equals k times x, where x and y are directly proportional. Except instead of y and x, we're going to use d and t. So we're going to say d equals k times t. So if we look here, let's say I take one entry here. I take the first one, and I look and I say, okay, so when d equals 1, t is equal to 2. And if I use this formula, d equals k times t, I'm going to plug in, I'm going to have 1 equals k times 2. And when I want to solve for k, I just divide both sides by 2. So this tells us here that our constant k is equal to 1/2, which would tell us that our formula d is going to be equal to k, which is 1/2, times t. And if I look at all of these entries, go ahead and work this out. If you were to take the column t and multiply it by 1/2, you see 4 times 1/2 would give you 2. If you took half of 10, you would get 5. If you took half of 16, you would get 8. So this formula is looking good. So now for the next part here, we want to see how many seconds it's going to take for the robot to travel 11 feet. Now, one thing we have to be careful of here, please don't do something like this, d equals 1/2 times 11. Okay, this is a very dangerous bear trap because they're telling us to solve for how many seconds it's going to take for the robot to travel 11 feet. And we're going to use our equation. So for this, we're saying, well, when distance is equal to 11, what is time equal to? So when we plug into this equation, we're plugging into the left side, not the right side. So we would have 11 equals 1/2 times t like this. And if we want to solve for t, one thing that we could do here is divide both sides by a half like this. And that's going to get the 1/2 on this side to cancel, which would tell us that t is equal to, and now we're dividing a whole number by a fraction. So we could use, once again, what I'm thinking of keep, change, flip. I keep the term on top, 11. I change the operation here to multiplication, and I flip the fraction on bottom to 2/1. And this would give us t equals 22. So how many seconds will it take? It's going to take 22 seconds. So our solution here is 22 seconds. So question 43, we have Diane is planning a party at a trampoline park, and it's going to cost $55 to rent the park, plus an additional $8 per guest. And she wants to spend less than $100 on the party. We need to write and solve an inequality to determine the maximum number of guests G that can be invited when spending less than a total of $100. So for this one here, we want to pay attention to the $55 is the fixed cost. Okay, so this is fixed, and the rate here is this $8 per guest. So this is going to tell us the rate. So when we set up our inequality here, Diane is paying $8 per guest, and the guest is represented by G. So we're going to say 8 times G plus 55 like this. This is going to tell us, in a sense, like the total bill. Okay, and we need this total bill to be less than a total of 100. So we're going to set this to be less than 100 like this. So if you take a moment to think about this, this does capture what's going on here. And once again, some students get tripped up over which direction does the inequality go. But it's going to be less than, because if you only have $100 in your pocket, you can't have a total bill that's more than $100, because then they wouldn't allow you to purchase the services. So it has to be less than 100 here. So now we solve this inequality. We're going to start by subtracting 55 on both sides. So when we subtract 55 on both sides, this is going to cancel on the left. And on the right side, 100 minus 55 is going to give us 45. And we're left with just 8G on the left. Now to get G by itself, we divide both sides by 8. And now this is going to cancel out. And we have G is less than, and 8 is going to go into 45 5 times with a remainder of 5. So we're going to have 5 and 5/8. But think about this very, very carefully here. The number of guests has to be less than 5 and 5/8. We need to have a whole number of guests. That's why they said, what is the maximum number of guests? So we're only talking about a whole person here, okay? We can't have a fraction of a person. So the number of guests that we could have maximum here is going to be 5. So let's just record our answer. We could have a maximum of 5 guests. So question 44, we have a student tosses a fair coin with heads on one side and tails on the other, and they roll a fair number cube with faces numbered 1 through 6. How many different outcomes are possible? And we have to be sure to provide the sample space for all possible combinations to support our answer. So for this one here, what I'm thinking of right away is I'm using the multiplication principle. So if we're doing two things, we're tossing a fair coin, there's 2 options. We could either get heads or we could get tails. And now we're going to multiply that by the number of options for the cube. Well, we could either roll a 1, 2, 3, 4, 5, 6. So that's 6 possibilities. So we're going to multiply the 2 possibilities for the coin by the 6 possibilities for the fair number cube. And 2 times 6 is going to give us 12. So there are 12 possible outcomes. So for the last part of this question, we have to provide a sample space with all possible combinations. So for the sample space here, we just want to think about what could actually happen for the student that tosses the fair coin and rolls the fair number cube. Well, first up, let's consider the possibility that they get heads here when they toss the fair coin. So they could get a heads, and they could also roll a 1. So they could get heads and roll a 1. They could roll a 2, and then 3, and then all the way to 6 here. So these are the first possibilities when they're tossing the coin and rolling the fair number cube. But what they could also do here is they could toss the coin and they could land on tails. So they could toss the coin and get tails, and then they could roll a 1, and they could do this also for the remaining numbers up to 6. So these are the other possibilities here. And if you were to count all of these possibilities, there's going to be 12 possibilities total. And I'll just go ahead and throw curly brackets on like this just to contain our sample space. but these are the 12 possible combinations. So question 45 is our last question, and we have a scale drawing of a floor of a rectangular shaped classroom is shown in this diagram below, and the drawing has a scale of 1 inch to 14 feet. And we want to know what is the area in square feet of the actual classroom. So for this, we have to know that the area of a rectangle is length times width. But the problem is if we just multiply 2 times 1.5, that would be finding the area of the diagram in square inches, not square feet of the actual classroom. So the first thing we want to do here is find the dimensions of the actual classroom. So we'll say the actual classroom is going to be measured in feet. So I'm just going to draw another rectangle like this. I know this is not actually the classroom here because it's about the same size as this, but we're going to put the units here in feet. So now we just want to think here using the scale. 1 inch corresponds to 14 feet. Well, how many feet would that correspond to in this diagram here when we have 1.5 inches going across the bottom? So I could just put an X here and say feet. And now if I cross multiply, I have 1 times X is X, and that's equal to 14 times 1.5. Now I'm doing that math in my head, and what I'm doing is when I multiply 14 times 1.5, 14 times 1.5 is the same thing as doing 14 plus half of 14 is 7, and 14 plus 7 is 21. So that's how I'm doing that without a calculator. So X equals 21, which tells us this dimension across the bottom is 21 feet. And now if I do something similar here, how many feet is that going across the top? Well, if 1 inch is equal to 14 feet in the scale, well, to get 2 inches, I would just multiply this side by 2. But if I multiplied the left side by 2, I would have to multiply the right side by 2 like this. So I have 2 times 1 giving us 2 inches on the left would correspond to 2 times 14, which would be 28 feet on the right side. So the 2 inches going this way would correspond to 28 feet. So now I could go ahead and label this. I could say that the length is, let's say, 21 feet, and I could say that the width is equal to 28 feet. And now I'm just going to go ahead and find the area of the rectangle. So the area of the rectangle, we're just going to multiply. We're going to do 21 feet times, we have 28 feet. And we could just work this out here. I'll just go ahead and do the long multiplication on the side. So we're going to have 1 times 8 is 8, 1 times 2 is 2. We're going to put a placeholder. 2 times 8 is 16. We carry the 1. And then 2 times 2 is 4 plus 1 is 5. So this works out here to 588. So we're going to have 588 square feet. If I were to write it out the long way like this, I would have 588. And square feet, I would write feet to the second power like this. But this is going to give us our solution. Question 46, we have a scuba diver dives 24 feet below the water's surface, and then the diver rises 10 feet, stops, and then dives downward another 18 feet. How far in feet does the diver need to rise upward to reach the water's surface? So for this one, I'm imagining here's the surface of the water, and the diver first dives 24 feet below. So I think of that as going minus 24 like this. So they're going down 24, and then they rise 10 feet. So they go from minus 24, they're going to go up 10 feet. So they're going plus 10. Then they stop, and then they go down another 18 feet. So they're going down 18 feet from this position here. And we want to know how far does the diver need to go up to reach the water's surface. So for this, what I'm imagining is that the diver is going minus 24, then they're going up 10, and then they're going down 18. So this is the integer problem that we have to work out here. And if we work this out, negative 24 plus 10, that's going to give us, we're going to have negative 14. And then we're going to have, when we combine these two, minus 14, and then we just tack on our minus 18. And then negative 14 minus 18 is going to give us negative 32. The math that I'm doing in my head, if you're wondering how did I do that in my head, I'm taking the minus out in my head, and I'm doing 14 plus 18, and that's going to give us 32 on the inside. And then I just reattach the negative like this. So the diver is going to have to go up 32 feet. Question 47, we have a family of 2 adults and 2 children went to a fair, and the cost of admission and rides are listed below. And we have the family spent a total of $52 on admission and rides. How many rides did the family pay for? So now let's think about how do these prices fit within the total bill. Well, there's 2 adults in this family, and adult tickets cost $11 each. So we're going to do 2 times 11 to represent the cost of the adult tickets. plus the kids' tickets are $5 each. So we're going to do 2 times 5 since there are 2 kids in the family. And then what we also have here is that rides cost $1.25. So the rides are $1.25, and we'll say the family paid for X rides. So if it's $1.25 per ride, we're going to tack on here 1.25 times X. And now finally, this we could say is equal to the total bill, which is $52 like this. So now we just have to simplify. 2 times 11 is 22, plus 2 times 5 is 10, plus we have 1.25x, and this is equal to 52. So now we could just combine like terms. We have 22 plus 10 is 32, and then we just tack on our 1.25x, and this is equal to 52. So now just subtract 32 on both sides, and that's going to get the x term by itself. So we have minus 32 plus 32 canceling out. And now I'm going to write the results over here. We're going to have 1.25x equals, and 52 minus 32 is 20. So then all we have to do here is just divide by 1.25 on both sides. So we're dividing, and the rest here is just calculator work. You could just do 20 divided by 1.25, and that's going to work out to 16. So we could say the family paid for 16 rides. So question 48, our final question. We have Airline A and Airline B offer travel discounts to the same destination, and the original ticket prices and discounts are described below. Which airline offers the least expensive ticket? And we have to be sure to include the discounted ticket price for each airline in our answer. Okay, so let's start with Airline A. So we'll say an Airline A ticket. So an Airline A ticket cost, and if we look here, it's 25% off of the original price of $150. So one thing that I think of with something like this is if I'm taking 25% off, I want to know what percent is still on. So if I take 25% off, 75% of the original price is still on, because if I do 100 minus 25, that's going to give me 75. Okay, so when I'm finding the discount price, I like to use the percent on rather than take the percent off and then subtract it, because this is faster. Okay, like doing it this way, like looking at this value is faster. They're both correct to use, but I like to use the percent on. So an Airline A ticket cost, and now we just have to do the math here. We're going to take the discount, but we're going to use the percent that's on. 75% is 0.75. Okay, if that's something that you just can't do in your head, it's fine. 75% is the same thing as 75 out of 100, and that works out to 0.75. So the Airline A ticket cost 0.75 times the original price is 150. So when we work this out here, this is equal to, we have 0.75 times 150, and this is going to work out here to $112.50. Now just know, if you want to take 25% off, you could do 0.25 times 150. And when you see the discount here, we're just going to do the original price, 150, and we're going to subtract the discount here of $37.50. And notice that we get the exact same answer of $112.50. But once again, I like to just multiply by the percent on, because it gives me the answer in one direct shot. So an Airline A ticket costs $112.50. So now let's shift over to Airline B. So to find the cost of an Airline B ticket, we have a discount of 1/3 off the original price of $180. So what I'm thinking about here is, if we take 1/3 off, I want to know what part of the price is still on. Well, that would be 2/3 is still on, because if I did 1/3 plus 2/3, that would give me 3/3, which would give me 1, which is the entire price. So what we're going to find here is we're going to do 2/3 times $180 like this. And if I want to do this without a calculator, I'm doing 180 divided by 3 is 60, and 60 times 2 is 120. So this is the cost of an Airline B ticket. And one thing to note here is right away I could see that Airline A is the least expensive ticket. But if this didn't make a whole lot of sense, another way to visualize this is if you look at a diagram here of the fraction, and I'm going to cut this entire circle here into thirds, and I look at the total price is 180, and I label all of these as 60. Notice that these are equal parts here, and 60 plus 60 plus 60 is 180. If I take 1/3 off, you see how I'm left with 60 plus 60, which is 120. So that's just another way to visualize why the discounted price is 120. But if we have to just cite our answer here now, we're going to have to make a choice. Airline A is the cheaper ticket.